Okay, so yeah, again, reminder to everyone, this is being recorded and will be posted online. Ilya is scribing, and as far as the next call goes, I started it scheduled for August 22nd, but I will be out of office. So this earliest possible I can make it is August 30th.
This would be the triage call, or which one?
This would be a triage call. So yes, I guess you could also run this one without me if.
Todd, you're driving the triage schedule. How do you feel about that?
I think it's useful to have Yoav on the call, given the number of specs he's actually the active editor for. So, how is August 30th for everyone?
30th works. Let's just do that.
Yeah.
Okay. So August 30th at 11 PST.
30th doesn't work for me.
Plus minus a day.
Well, I mean, 31st is Saturday. I'm fine with Saturday, but I suspect.
No, let's not do Saturday. 29th, Thursday, 28th.
I'm not around.
Okay.
Yeah. Yoav gets back in the office on the 30th, so that leads us into the next week, which is 2nd, 3rd, 4th, 5th. So
yeah. So we could do 5th. So theoretically, the 5th is scheduled to have the next one, which is a design call. Maybe we could, I don't know if it's a good idea, but maybe we could have 2-hour back-to-back of triage plus design in prep for TPAC. How do folks?
On the 5th?
On the 5th.
Do you suggest something like a 10 a.m. through 12 PST time?
Yeah.
It's a PDT time. Yeah.
I think that makes sense. 10 to noon on that day for design followed by triage.
Yeah.
Okay.
Cool.
Okay.
All right.
Awesome. Okay, so with that out of the way, let's talk about TPAC. We started document sketching out a rough idea of what the agenda may look like. We have Monday and Tuesday there, and we were talking about the division between those into which parts we need for design, which parts for working on issues, and if we're working on issues, should we go for triage-related discussions or more hands-on sessions where people actually get work done?
So one FYI is that I won't be there on Tuesday because web components, again, they got scheduled overlapping on Tuesday. So yeah, if there's any topic where you'd rather have me, then we need to do that on a Monday.
Okay, that's great input. Can you fill? So yeah, and generally, folks, can you fill out the attendees section in that in the linked document for TPAC agenda in order to just tell us if you'll be there in person or remote and on which days. So that way we can, better plan for, for the various subjects that folks need to be on. And otherwise, other than attendance, we were thinking of basically what new, big new subjects we will need to discuss there. So 3 themes that, 3 subjects that arise at the face-to-face were CPU reporting, which we'll talk about today. Utkarsh will present about that, but we may want to basically go from a use case document or from a problem statement into something that looks more like a solution. And then we have single page app monitoring, which is still at a fairly early phases, and frame timing that we want to understand if the current outlined solution can solve the problem, and to see if it can solve it in a way that doesn't reveal history with various visited related attacks. Does that make sense to folks? Do we have any more agenda items or any more new features that people want to incubate or like to discuss during TPAC?
I'd like to maybe discuss a little bit about some of the features or the changes to the resource timing spec that we're thinking about for visibility into cross-origin iframes, and if we can get any visibility of iframes out there. And similarly with the kind of the bubbles feature where we can easily notice all iframes activities on the page as well. So even if we just talk for half hour about that, it might be nice. So I can put that on the...
Yeah, if you can put that on the agenda scratch pad, yeah, that'd be great. I don't know, like, what do you mean by visibility into cross-origin iframes?
Yeah, I had filed an issue with some thoughts on this, but basically giving cross-origin iframes the ability to opt in to sharing some of their resource timing data. Yeah.
Okay. Yeah, so yeah, if you can add that to the agenda. And yeah, anything else from folks? Anything else you feel like we should be discussing?
There's a few specs that we need input from folks outside of this group. We talked about reporting and NEL. There's some outstanding feedback, so I think we'll have to reach out and see if we can loop in some of the folks that are missing from this group to resolve those. Ben, I may lean on you to get some feedback from Mozilla on those, because I think you guys have some good feedback, but we just need to figure out how to untangle it and make it all work.
Okay.
Cool. And otherwise, Utkarsh, I see you added yourself to the attendees list, so you'll be there in person, and yeah.
Okay, great. So the AIs, just to recap, the AIs are, there's a doc that's been shared on the public WebPerf mailing list. It's also in the minutes. So please go inside and add yourself to the list of attendees. If you're remote, let us know as well. We're trying to figure out how are we going to support that better, hopefully. And please add any topics there. And I think we are landing on first day as design discussions, second day is roughly issue triage, but those are malleable based on who we need in the room for what.
Yeah. Okay, cool. And moving on from that, the next subject is CPU reporting. And Utkarsh, do you want to present?
Yes, so I have a little slide deck that I can share actually. Okay, just shared. Let me know if you guys see my screen.
Yep.
Perfect. Alrighty. So, hey, this is Utkarsh. For those of you who don't know me, I work at Akamai on web performance related problems. So today I wanted to talk about some of the use cases around CPU reporting that I've been trying to document and sharing it publicly with developers everywhere. So in the last face-to-face meeting, there was a lot of interest from developers around how they could be tuning content if they could know how powerful the device was. And we all know that the user agent, although it contains a lot of interesting information about the platform, the browser, it's not a strong indicator of how powerful the device is, right? And so there was interest in a potential of browsers exposing information about uh, the CPU of the end user's device. And so the discussions were around, what makes a device slow? Is it only the CPU that will make the device slow? An old phone with a slow CPU processor could be slow. A fast device, but in a battery saver mode, could also make that fast device slow. The device may have faster cores, but the device may already be under heavy load. So all of these things, and there are potentially others that will make the device slow. So focusing on, if the browsers could expose CPU related information back to the developers, how could they be using this information? So the document I started some time ago collects all the developer use cases, and a lot of people have actually added various use cases around image optimizations, how to make pages simpler, how to block certain requests, and which I'll go over. So I try to categorize different use cases into different categories. So one of the ones is blocking certain requests when we know that the device is slow. And the blocking could be for third-party requests or JavaScript libraries that are super bloated and are not really needed. And it's okay to not load them when the device we know has very constrained resources. It's not fast enough, and it's going to not improve the user experience. Other use cases were around, if we could know that the device is slow, then try to build less complex pages that are not JavaScript heavy. We could think about removing animations from the page, replacing image carousels with static images, and even use lower compression levels when uploading the data. And this may tie into the upload compression proposal that we've been talking about. So overall, think about delivering AMP-like pages, which have a very, very stripped down version of a subset of HTML semantics, and even JavaScript-less pages. Think about delivering features to the page that do not require polyfills. So try to build websites with already natively supported features that most browsers already support. The other category that I thought of was running some sort of computation on the cloud whenever possible. So for example, AMP server-side rendering, it tries to figure out the layout of an AMP page and puts all the layout specific information in the AMP HTML itself, and only then deliver to the client. And that helps speed up the rendering time, and as well as some other metrics that help improve the user experience. So this is one of the things that could be done on the cloud and then pushed to the client. Puffin browser tries to do some of the JavaScript heavy computations back on the cloud, and then send some sort of a JavaScript heap to the client, and then it processes the JavaScript heap. So in the end, the device is doing less computation on the CPU, and so the page loads faster. And there are a few academic papers that talk about generating JavaScript heaps in the cloud, and of course, they have some limitations. Another use case around improving the performance of ads was also ties back into doing some sort of machine learning in the cloud to know which specific ads may perform better on slow devices, and only selectively push those advertisements out on the pages. There were a bunch of use cases around how to optimize for media resources. So if we know that a device is slow, one may think that it's likely that a slow device is probably an old device, and also that means that the resolution of the screen is not too high, right? And so delivering a pristine image or a pristine image is not a good idea. So apply optimizations on that media resources so that we can serve low resolution images or media documents, or even think about sending media resources in a specific formats that are not too expensive on slow devices. Actually, I think someone actually mentioned the document that WebP seems to seems to take a lot of computers, a lot of decoding time on slow devices. And so if we could identify that, hey, this is a slow device, maybe let's send an image in a different format that decodes faster on the device. And I think your proposal around resource processing time that tries to estimate how long a resource took to process on the device, be it JavaScript or images or anything that happens for the resource, I think would be helpful in measuring how long different types of resources take on different types of devices with varying CPU characteristics. So we don't only have to think about slow devices, and in fact, we could specialize for faster devices. If we know a device is faster, we could do something on the back end as well, and try to conditionally run certain JavaScript tasks when we know that the device is fast or is not under heavy load. We can selectively choose when to run certain tasks given the instantaneous load on the device. But this would also require some sort of an API, a JavaScript API that browsers could expose that could tell whether the device is currently loaded or not, or this is how much the CPU utilization is or has been in the last X seconds. It would also take a user parameter that allows the browser to expose the CPU utilization for a user provided number of seconds. So it's open for discussion about what that API may want to expose. Should it expose the per core load or the total CPU utilization? And a lot of it may depend on what is available or what is reported by the operating system at that point. Some use cases were around how we can associate the CPU information with a lot of performance-related metrics we are already collecting using RUM systems, right? So we may think about looking at page load time or certain aspects of JavaScript performance and tie that back into how slow or fast we classify a device is. Things like looking at how much traffic a particular website is getting from slow device versus fast device, and think about, is it really, do they really need to optimize for slow devices given they're getting only a small fraction of traffic from slow devices? And this may be opposite for another website, which is getting a lot of traffic from slow devices. And so it probably makes more sense for them to think about how they want to optimize their website for majority of their traffic, which is coming from slow devices. So, so I've been talking vaguely about slow and fast devices, and there is no crisp definition of what makes a device slow, right? As I said, a device which is fast today may not be fast tomorrow, right? Because a lot of it depends on how much CPU utilization it's going through right now. If it's already super loaded, then for us, for the next content that it's going to process, it's already under heavy load. So, one idea that came up was, what is fast enough, right? And application developers may want to think about what type of devices are fast enough for their applications. So one example could be any device that has a CPU clock rate of more than 2 gigahertz. Maybe it's fast enough for that one application, or maybe that one application thinks that anything that has more than 1.5 gigahertz of clock rate is fast enough, right? So developers may need to identify their independent needs for their applications and think about what is the performance, how fast should the devices be in order for their users to get optimal experiences. So the slowness of the device, like I said, may also depend on the CPU utilization in the past few seconds or few minutes, and it could fluctuate a lot because a lot of different applications run on the device, and different pages require different resources on the CPU. So depending upon the user browsing behavior and or the other applications running on the device may contribute to how much CPU utilization is a browser could report, right? So this number could fluctuate. Number of CPU cores may be an indicator of how fast or slow a device may be. Dual cores versus octa-core versus deca-core. So it depends on how the application is written. Number of CPU processors may be another interesting one, because if a device has multiple chipsets versus one chipset, then a device with multiple chipsets is likely to have at least one processor faster than the other one, and that is also used when the battery saver mode is activated, because the device turns off the power hungry faster processor core and moves to the slower processor. Clock rate may be another metric of interest for some developers. So over time, like I said, a device which is fast today may not be fast tomorrow. Applications are evolving, and their requirements for speed are only growing. So if we classify devices based on any of these categories, these classifications will need to be updated based on how the applications are being updated, and how the mobile market is moving forward, bringing faster and faster devices as the users are moving toward faster devices. So moving on to so now we know that we have lots of use cases, about 20 or so use cases, where we know developers want to do so many things if they could know how powerful the device is. So now the question is, what sort of information can we think about browsers exposing? Right, like I said, cores, processors, clock rate is one. Maybe some sort of a browser bucketed way of telling the developer that the device is very slow or fast, right? Or some sort of a score that lets the developer know, hey, this is 5 out of 10 or 7 out of 10, but that score needs to be changed, because we also don't want newer devices to approach 10. The score needs to be changed as well. Number of CPU instructions that are run in the last X seconds was another thing someone mentioned on the document. But if we end up doing that actively, that the experiment itself is going to consume a lot of CPU resources and may interfere with what else is being loaded on the browser. So I was wondering if if browsers can actually measure that passively. I don't know if you guys have any thoughts, or if you know if that is even possible today. Okay.
So yeah, I think one of the the main concern, which maybe you should somehow not take it into account when talking about the use cases, but is definitely something you should take into account when talking about the solution, is the fact that we want to minimize the number of bits that this information exposes as far as users are concerned. So yeah, we want to, make bigger buckets rather than have a very specific one.
Yeah. So So going over the use cases, I didn't really come across any use case that specifically needed any of these properties being exposed, like CPU cores, or processor, number of processor, or clock rate. There weren't any use cases that required one of these things specifically. So one of the other things, like I said, could make a device slow is the battery saver mode. And I don't think the browsers expose whether the battery saver mode is active or not. So maybe that could be another strong indicator of something that makes a device slow. So maybe that is something browsers may expose. The next goes into how and when should this type of information be exposed, right? Should it be an opt-in from the server side? Should it be sent in every HTTP request, or should it be a JavaScript API that the browsers could expose? Or should it be done just once during the TCP handshake, which I don't think would be a lot of value if we go with if we go with exposing the CPU utilization information, because that fluctuates a lot. And so just sending that information once is probably not of much use. So a couple candidates here are exposing CPU information via JavaScript API, or exposing that information in every HTTP request. I'm not sure if there are any other ways they think of how it could be.
On every HTTP request is probably not a good idea privacy-wise, but as a client hint, so on HTTP requests, but as an explicit server opt-in, could be an option.
Yeah.
Coupled with a JavaScript API.
Yeah, that makes more sense. Yeah.
Yeah, and maybe we should move. Yeah.
Okay. Yeah. So there were a couple of concerns about how exposing CPU information could also lead to device abuse and user fingerprinting. And the device abuse cases where a malicious website, where it knows that the device is fast, may try to run computationally heavy scripts such as crypto mining, or maybe reload ads frequently, load even more fourth-party resources. Although some of it is already possible if one tries to map user agent strings with publicly available CPU information for every device from websites like GSM Arena. But it's not as easy as having browsers to expose that information explicitly. About user fingerprinting, concerns about cross-origin tracking. If a malicious user or attacker had control over multiple websites, and the user is interested in some of those websites, sending the same information to all of those malicious websites may expose or may help fingerprint the user. So maybe we need to think about how to fuzz some of the CPU information we expose across the origins, and maybe fuzz a little bit every time it's asked from the same origin.
All right. When you say fuzz, you mean like reduce the granularity or specificity?
Right. Yeah.
Okay.
I mean, to me, this is the sort of showstopper issue, right? If like right now, script can't tell which version of, let's say, iPhone user has, because there might be enough variance per device. If we expose how fast the device could be, or there might be, that's enough to probably distinguish which generation of iPhone the user has, and that's just not okay.
I think the challenge here with a lot of this, though, is so this has come up recently internally around the browser's network estimator code should give more information about the speed to a particular target, right? And the challenge with all of these things is they can give you a snapshot of instantly, but not tell you what's going to happen like in 5 seconds.
Yeah.
And so ultimately, the only way to do this even remotely reliably is to just try it. So rather than ask the browser how fast is the connection, you probe the connection and see how fast it is. And that'll at least give you an instant value that's accurate. as opposed to an expectation of, some fuzz thing. And so like the idea of, crypto mining, only doing crypto mining on fast machines, well, first off, they would probably just run the stupid thing. But secondly, the real thing you would do is you'd benchmark your little benchmark script, you'd run it and say, is this fast enough to meet our criteria? And then you know. And so like the idea that an iPhone can mask itself from discovery about what the underlying CPU is a little bit silly, because there's 50 iPhone models. You run them in a lab, see how fast it runs, and now you know exactly which model it is. And so I think the idea of hiding it is challenging. And then the other piece of like giving an indication of what else is happening on the system is, the browsers have sort of worked hard to try and avoid leaking that information, because they can reveal things about like what other sites the user is logged into. And so, hey, I try and load this frame, and if it does a ton of work, that user is logged into that site. And so I just watch my CPU usage and see, oh, look, there's a lot of CPU usage going on right now. And so that user like is doing some expensive login in running, as opposed to getting a 404, you need to log in page. And so I think a lot of this info is already in the user agent in one way or another, but its applicability and the ability to make decisions based on it is a little, I think, troubling, right? I think it, a lot of the scenarios come down to, hey, we'll give the user fast content if their device is slow. And I think there's a lot of examples that suggest giving the user fast content even on a fast device is a good idea.
Yeah. So coming back to your idea around benchmarking and seeing how fast something runs, I think that benchmark is only valid for that one instance of the benchmarking, because maybe the device wasn't overloaded that time, and so the benchmarking you did gives you good numbers, but then next time you try to actually load something on it, which is going to be used by the real user, the device is super loaded, and the benchmark you collected earlier is not applicable anymore.
What I mean to say is you benchmark on the user's device. So like when I go to Netflix, it drops like 2 megs over an XML HTTP connection to see how fast my connection is. And then it gives me a different user experience. And that's again, like you're right, that, hey, the device after that benchmark process runs could suddenly come under load. But that's true of anything, right? Like if we tell the user their device is fast, and then they start building Chrome in the background, my benchmark results was no longer, even if the browser tells, the one thing you can get out of this information is like, what is the theoretical peak performance of this device? But that, that is the user fingerprinting problem.
Yeah, and it's just not related to browsers. It happens in so many areas, even with CDN mapping. We look at historic data and try to figure out the performance of different links on the internet and try to figure out where to send the client. But we do that based on the historic data, right? The past 30-second data. And when we send the client, we don't know how fast it's going to run at that point, right? So
also, many of the examples you listed are very largely affected by whether the certain hardware encoding or decoding happens in the device, right? Or like what kind of browser is being used. Performance of JavaScript is so different depending on which browser is being used, right? And which version of browser is used.
Yeah.
CPU performance may not be almost irrelevant, because depending on the browser, maybe something runs 10 to 100 times faster than other browsers.
Sure, but the user agent string already gives you that information, and even in future plans to clamp that down, that information of which browser is doing the processing will also be available. But
that's not true, though. We don't expose the information in Safari anymore, so
Right. Well, part of this scenario, right? Like, do you have hardware decode on your GPU for a particular media format, right? Like some of that information at some point was exposed through the WebGL APIs, and they're like, oh, that's too much data. But I guess the overall point is, like, the notion of having generic, general purpose, give me one number to get the performance of the machine, usually is inaccurate for the workload of, like, yeah, if I'm doing hardware encoding or decoding a video, like the CPU is almost irrelevant as long as I'm getting the hardware decoding capability. And similarly, you may have wildly different performance characteristics. Like I could have 8 tiny cruddy ARM cores, or I could have one blazing fast i9, CPU core. And just the number of cores is not necessarily going to give you the thing that you're interested in. It might, help you tune the number of workers to spawn, but
Ben, at the
Well, I mean,
face-to-face,
there's no guarantee that OS lets you use all the cores either. I mean,
Yeah.
right.
Yeah.
Is there any consensus that if just some idea of battery saver or kind of clamped clock, is that going to get us 80% of the way there with this stuff?
exposing power saver status is a showstopper. That is just not okay from user privacy perspective.
Yeah.
There's a study of research showing that the websites are using that to track the user. In fact, the people who have more money tend to always keep the battery full and don't use power saver. So like this is just like showstopper over showstopper. That is just simply not okay.
Okay. Can you put the link to that study somewhere, Ryosuke, please?
I think it also is related to the battery status API of like, what is the level of the battery? And there was a lot of concern about revealing that to websites because somebody had hypothesized that Uber could charge you more if your battery was about to die. And even though I don't think that was a thing that ever happened, it is now in the lexicon as a thing that happens. And so various browsers have ripped it out and said, we're never going to do that. But I mean, the other question I would have is, are sites using these sorts of signals today? And so the one that immediately comes to mind is the data saver client hint. Like, are we seeing a significant number of sites adopting that and doing something useful with it? Because I feel like that would be the same class of thing. Like, are we seeing data saver use, and are they reacting differently?
So data saver may be a little different of an indicator than device under heavy load. Right, the user is with the data saver. The user is interested in saving the data because it has a limited cap on the monthly data plan that the user has. But it does tie back into reducing the size of the content we ship it to the user, but mostly because to ship less stuff, but not less complex stuff.
Right. So my real question is just, are websites reacting to the signals available to them today? Because I'm personally questioning whether or not sites that are in a position to be doing things based on these signals are actually using them.
I can speak to that a little bit. On the Google and Chrome partnership side of things, in the last year, we've seen an uptick in the number of large sites, so eBay, Facebook, Tinder, who are interested in differential loading and are using the available signals on the platform. So effective connection type, any memory signals we've got available, battery status even, in order to send down lighter experiences or turn off the serving of heavier features to devices they don't think can handle them. Lacking a clear platform signal for CPU, some people are starting to explore client-side benchmarking to get some idea of CPU over time. Some people are doing a little bit of sampling over the lifetime of the user to get an understanding of that. Other people are doing interesting things like mapping. So using the UA and other signals available, can they build up a database of what we think your device is and then cross-reference that with deeper information about your CPU and how things are decoding, et cetera. So there is an increase in interest in this from real sites as far as I'm seeing.
So if this is not standardized, does that mean that potentially multiple vendors are going to be doing this, all in a different way, all wasting user resources?
I think that's a real concern. Yes.
Like, you don't have to run the artificial benchmark, right? You can just observe what websites are normally doing and observe how long each one's taking and use that information to inform that, wait a minute, this is taking too long, maybe we should not do that.
So you're just talking about page load stuff, Ryosuke?
I'm sorry, what?
Are you just talking about page load, looking at the existing page load info?
Not even page load, but like let's say that you're showing some a chat pane on the side, right? And maybe each time chat pane gets updated, maybe you're gonna measure whether you're missing a frame based on request animation frame. If you're missing a frame every single time, maybe you're updating too much. Maybe
Yeah, but
be shown. I mean, there are many things you can do even today without any new API to measure how well your website is performing on a device as the website's performing.
sure, there are many things you can do. There are things you can do passively. They are more complex to develop than active measurement, and therefore people tend to do active measurement more if this is something they're interested in. And it's very hard to, like, that doesn't address, like, relying on passive measurements doesn't address most of the use cases, I think, because in some cases it's too late. By the time you're missing frames, you're already too late. You already delivered the bad experience to that user. It also doesn't enable you to correlate performance based on different device speeds. But yeah, at the same time, there are real fingerprinting concerns and real concerns about how many bits and which bits we can expose as part of that. And I think that the use case is viable and real, and not something that people can just do with passive observations today. At the same time, we need to estimate the trade-off between this and user privacy and see what's basically, how many bits we can expose. I know that in the past we talked about something like Facebook's device year or device class, where they classify devices based on some perception of, in this year, that was the average device, or the 80% percentile device or something along those lines. And I'm wondering if this would be something that would satisfy the use cases, because it's like, it will expose a relatively low number of bits, even though it will expose some. But have we looked at the use cases through that lens and seen if this is something that will help resolve most of them?
So from what I remember about the Facebook's year of class model they had for devices, so what they did was that they would look at the CPU information of different devices and figure out the average. They will look at when that phone was released, and say it was 2010, and they will look at the average CPU that was released for phones in 2010, and that would say if any device that belongs to this CPU information that is from 2010. Even though the device was launched in 2017, they would still classify it as 2010 because they have the same CPU information. So I did try to look at some data that I collected from GSM Arena around, how fast and slow the devices are based on number of cores and processor speed. But I didn't really have a strong inclination towards using that information and tying into Facebook year of class yet. I'm just wondering what's the motivation here? Why do you think that could work? I mean, I know the exposing bit would be that this belongs to 2010 versus 2017. But I'm wondering if that is a strong enough indicator. Right, just exposing the year may not be interesting because every developer would need to know what that year actually means, and they may need to work with the data set that Facebook has, or think about what that 2010 means for their application versus what 2017 means for their application, as opposed to working directly on the CPU numbers.
So if I was to reframe maybe Eov's question, maybe the year is not the right thing to fixate on. I think the question is more around on the spectrum of how much information you expose. Like there's a static single bit that you could expose, or maybe some very limited number of categories. It could be a year, it could be fast, average, slow, 1 to 10, ABC. I don't know what it is. It's just like some very limited set of signals. And then moving up that line, at the other extreme, it could be like literally, here's how many CPU instructions I've been able to execute in the last 5 seconds. And I think we all agree that that's highly unlikely, both for technical and many other reasons. But I'm also hearing from other folks chiming in here that like many of the things in between feel uncomfortable. Things like battery exposing, whether you're on battery saver, which definitely has implications on your CPU, is unacceptable. We've heard that even providing kind of more direct signals towards which device you may be running on iOS may not be. So it's finding like how many of the use cases do we chop off based on these number of bits, if you will. And I think what Yoav is asking is like if we were to look at exposing some very limited class, right, 1 or 2 bits or 3 bits, like slow or fast, how many of the use cases that we have here would still be relevant or even useful, generally speaking? Because it seems like many of them are already kind of doable. They require more work, sure, but they're kind of doable.
Okay, thank you for explaining that. Makes sense. No, we haven't looked at that yet.
Ben, I meant to ask earlier, if I remember correctly, at Face2Face, you said you've explored the space previously. I'm curious if any of the use cases here like resonated with you in particular.
Yeah, the use cases, just to clarify, we had thought about that based on Jill's paper, but we have not actually implemented any of the CPU pressure metrics, just to clarify. Yeah, we were mostly interested in doing it as a way to not from a website operator perspective, but more from a browser perspective, where we would like to collect performance data. And if we knew from the performance data that the CPU was discounted, then we would bucket those performance results in a separate container. So that was our main use case, although we're very, of course, concerned about the privacy implications. So I wanted to kind of explore and see if there was a way to do this and keep some semblance of privacy. And it does not seem like we have reached a conclusion on that. And that's my gut feel on this.
Okay, so your exploration weren't for web exposed metrics, but for internal ones.
Yeah.
Even though you looked at privacy to avoid collection of PII.
Yep.
Okay.
Got it.
I mean, the fingerprinting thing is real. And I don't have a reference to that paper that Ryusuke was talking about, but I would really be interested in seeing it.
Mm-hmm.
I'm assuming that's similar along the lines of the high resolution timing type fingerprinting.
Yeah. So in terms of a path forward here, Utkarsh, first of all, thank you for doing all the legwork here. There's lots of good research here. I'd love to capture some of the, like, even if we can't provide an API, I feel like there's an opportunity here to provide some guidance for like, we know that there are classes of use cases here, and we can make some recommendations for how to like do or do not approach this sort of problem. So for example, I'm thinking of the one use case I think I heard from, I don't remember the person's name from Microsoft working on Excel, was like, I want to run some speculative calculations, but I don't want to run them if they're gonna jank my next 10 frames. but I still want to run them because there's value to the user. So now I have a chicken and the egg problem. It's like, how do you reason about that space? What is a recommendation to a developer today? In the absence of a Oracle API that, as Eric pointed out, does not exist because we cannot predict the next 10 seconds of your CPU execution cycles.
Could we just have a is dropping frames? Or does that run into the same battery saver problem?
In theory, that would be the long task API. Like in theory, like one recommendation here could be like, look, we can't predict the future, but you could have observed long tasks for a while and observed that you've been dropping frames, and because of that, you should do less speculative optimization, like, or speculative calculation, not optimization. Like that seems like a practical. I don't know if people use that in the wild, but it could be a recommendation.
Yeah,
Same thing with the input pending API too, as an indicator to back off a little bit.
Right.
Yeah, and frame timing and all, like that would solve, I guess, the long running app problem, and they could, arrive at a conclusion of whether they're running on a slow device or a fast one. It won't resolve the problems of, do I load video ads or image ads as the page, for a page load? Do I load this extra JavaScript library that gives me something like that is a nice to have feature of the page, but is not core functionality? I think this is a somewhat different problem.
I'm also wondering if the developer needs to have enough number of hints from the device that it has been slow 10 seconds ago, it has been slow 20 seconds ago, it has been slow 30 seconds ago. And so to see that the device has been slow enough number of times would make the developer believe a little bit more that, yes, it's in general, it's slow device, so let's do something now, as opposed to just looking at one signal of device being slow and acting upon it. Because that one signal may be because of a spike in CPU or something else.
Yeah, but at the same time, Eric commented earlier that exposing the general CPU state of the system has a lot of privacy implications that go beyond fingerprinting. So if I have, and the classic example that I also came to my mind is, I'm building a browser on my machine right now, and that is potentially valuable information, and I'm sure there are other. So you're using Hangouts, and that's taking 100% of your CPU now, and that is now information that is available to other unrelated sites. So there are, like, beyond just pure number of bits, this is also potentially sensitive information in other aspects. That we'll need to,
I'm also thinking from a developer's point of view. Would a developer want to have a historic view of how of the device load, or one signal is enough, right? And how we collect the historic view it's a different discussion.
My intuition is that we may have enough low-level building blocks to assemble a reasonable model to address at least some subset of the use case here. There is definitely some signals that are missing, like the ROM analytics or sort of thing. Although even there, maybe you can create some composite metrics to report back. And it may be, like, I think actually it is the case that there's a number of use cases here that we cannot address because privacy and fingerprinting, and that's just not a line that we're going to cross.
Yeah. But I agree that it would still be interesting to maybe break down the use cases, look at how you would address them today, if at all.
Yeah.
And, draw a path where we address, make it feasible to address at least most of them with some set of, like, not necessarily high-level APIs, but, some set of web building blocks.
Yeah, that's a good idea. So I also thought about the fact that the CPU load on the device doesn't have to be origin specific, right? And if the browsers could look at how different pages from different origins have been loading in the past whatever number of seconds, they could just come up with a score and say, hey, this is how slow or fast the device is in the past whatever number of pages it has loaded, and expose that information. Would that help? Because that is not an instantaneous CPU load. That takes account into how, in general, different pages have loaded in the past on that device, and so that sort of hints at the historic, like average historic load on the device.
I mean, if the user is taking a train and moving from station to station while loading page, though, it might be slow, right? And then user stops the train station, gets out of the train station, you get the fast Wi-Fi. I mean, totally breaks down in that scenario. Or like if you're driving, if you're in a car previously and then stop, right?
I think it goes back to, once again, what use cases would that address? Right? Like, I think we need to apply that lens and look through and then see if there's value. And I agree with Ryosuke. I think we were still leaking data across all these things.
Yeah. We're at time, but thank you so much for presenting. And I think we can continue to hash at those use cases and see which of them we could address in a privacy reasonable way. Okay.
Yeah, thank you, Ukresh, once again. And just to reiterate, I'd love to see some doc or some more thinking going on, and maybe I can help chip in there as well for how we can make some recommendations in the space, because I do feel like there's some really valid use cases here that people are trying to address today, and it would be really nice if we had some recommended path for them to, like, if you're building Excel and you're doing speculative calculation, here's how we recommend you do it. Like, here are the building blocks.
Yeah.
Yeah. Okay.
All right. Thanks, folks.
Thanks all.
Bye.
Bye.